Picture looking out into the sky at night, an endless and bottomless sea of blackness dotted with a sparkling spray of stars. They all burn as cosmic messengers, bringing stories from long-forgotten epics written before humanity set foot on Earth. For over a century, those twinkling points have challenged individuals to pose deep questions. Where did it start? How old is the universe? And maybe most unnerving of all, what if all the answers we have held onto for centuries are incomplete or even incorrect? In 2023, NASA's James Webb Space Telescope, the most advanced observing instrument humans have ever sent beyond Earth, provided data that rekindled those controversies. Among its revelations was a discovery so disturbing that it resonated throughout the astronomical community like a shockwave, a star whose estimated age seemed to be greater than that of the universe itself. If confirmed, such a discrepancy would break our most fundamental assumptions regarding cosmology. How is a star older than the cosmos it lives within? Is it an error, a peculiarity of physics we have yet to understand, or a hint that the timeline of the universe differs immensely from what we have assumed? The object in the middle of this paradox is just less than 200 light-years away within the constellation Libra. It is listed as HD 140283, but better referred to as Methuselah, after the biblical patriarch who is said to have lived to the remarkable age of 969 years. Methuselah is ranked as one of the oldest known stars in the Milky Way, a living fossil from the earliest ages of star formation. What sets it apart is not simply its age, but the overwhelming paradox it forms in contrast with the accepted timeline of the universe. Its age was initially estimated to be about 16 billion years, and that alarmingly exceeded expectations because the universe itself was only calculated to be 13.8 billion years old. Subsequent refinements changed the age to around 14.46 billion years, with an error margin of approximately 800 million years. Even this more recent figure, however, puts Methuselah uncomfortably close to, or in some accounts, even older than, the universe. It helps to go back over how the universe's age is calculated. Our standard cosmological model, the Big Bang Theory, holds that the universe came into existence at one moment some 13.8 billion years ago. Its explosive birth hurled matter and energy out in all directions, setting in motion the formation of galaxies, stars, and planets. By observing the rate at which the universe is expanding, astronomers infer how old it is. Light from distant galaxies is also redshifted, which means it has been shifted toward the red end of the spectrum. The more redshift, the more those galaxies are moving away. By measuring this expansion rate, scientists extrapolate back to the starting point. A further reason is also provided by the cosmic microwave background, the feeble afterglow of the Big Bang, which also verifies the 13.8 billion year estimate. If we telescope this into human-scale analogy, all of the universe's history would occur in the course of one calendar year. The Big Bang would happen on January 1st. The Earth would not even come into existence until late December, and all human history would occur during the last few seconds of December 31st. Given this timeline, Methuselah's alleged age comes to look very questionable. So how do we even approach measuring a star's age? Unlike trees, stars lack growth rings to be counted. Astronomers resort to indirect methods. They quantitate luminosity, the intrinsic brightness of a star. They examine surface temperature, spectral lines that betray its composition, and rotational velocity. A young star rotates faster, it slows down as it grows older. Methuselah moves slowly, as if time itself has taken its toll on it. Its chemical signature says otherwise. Stars are created mostly of hydrogen and helium, but as stars live and die over generations, they leave the universe seeded with heavier matter, carbon, oxygen, iron. Methuselah has very little of these, so it must have formed when the universe was young and still not contaminated with much heavier matter. These hints all point to a picture of outrageous age. And still, the mystery, can a star be older than the universe? Perhaps our calculations are wrong. Even an infinitesimal error in nuclear reaction rates fueling stars could skew the findings by billions of years. Or perhaps our cosmic timescale itself is flawed, that the universe is much more ancient than we have thought. This is where other cosmological theories come in. University of Ottawa physicist Rajendra Gupta has proposed a revolutionary reinterpretation of cosmic history. The universe is not necessarily 13.8 billion years old, but possibly 26.7 billion, almost twice as old, Gupta argues. This theory is constructed by marshalling two extreme notions. The first is the tired light hypothesis, first stated in 1929, that claims imply that photons slowly lose energy over intergalactic space. Over billions of years, this energy loss would simulate the redshift we now assign to cosmic expansion. The second is the idea that nature's fundamental forces, gravity, electromagnetism, might not always have been the same. Rather, they could change with time. If so, then much of our equations for the early universe would require redrafting. Such a model would beautifully account for not just Methuselah but other abnormalities too. The James Webb Telescope has imaged galaxies so orderly, so large, and so advanced that they cannot exist if the universe is just 13.8 billion years old. These galaxies look less than 500 million years after the alleged Big Bang, but they look as if they've had billions of years to develop. In Gupta's framework, they have had exactly that. Another issue is the Hubble tension, the discrepancy between two different measurements of the universe's expansion rate. Observations of the cosmic microwave background suggest one figure, direct measurements of galaxies closer to us suggest another. If redshift is partly due to photon fatigue rather than space itself expanding, these two methods could finally be reconciled. Skeptics reply that exhausted light cannot account for other important observations, like the manner in which distant galaxies look not merely dimmer in hue but also in brightness, or the manner in which cosmic background radiation sits so perfectly atop the predictions of expansion. Yet Gupta's theory compels astronomers to wonder if perhaps we've left something basic out. Methuselah is hardly the sole source of cosmic tension. The Gaia mission of the European Space Agency has been mapping the stars of the Milky Way to unprecedented precision. Its information indicated that stars at the edge of the galaxy move at a slower rate than anticipated. That suggests that the Milky Way has only a small fraction of the mass previously estimated, maybe even only 1/5. That questions our conception of dark matter, the invisible cement believed to hold galaxies together. If our galaxy is anomalously poor, why? Or worse, what if dark matter is not so? These anomalies are a set of puzzles. Each is perhaps not conclusive alone, but in concert, they imply fault lines in the pillars of our cosmic picture. Perhaps Methuselah is not anomalous but precursor. Maybe other stars like it exist, somewhere in the darkness, to be discovered. If additional ones are discovered, the scientific community may be compelled to rethink the ages of stars, the history of galaxies, and the universe itself. Think how many times science has come to such turning points. At one time, man thought the world was at the center of the universe. At one time, we thought the Milky Way was all the universe. At one time, we thought the universe was finite, unchanging, everlasting. Each of those notions fell apart under the weight of new data. Each time, the universe turned out larger, stranger, and older than we had supposed. Maybe this is just the next chapter in that unfolding history. If the universe really is 26.7 billion years old, then the philosophical implications are enormous. Man's life, already a brief moment, becomes even smaller. Our entire history would no longer be the last second on December 31st of the cosmic calendar, but a fraction of that second. It is a sobering consideration that civilizations come and go in shorter than the blink of a cosmic eye. But humility is not despair. Being a thinking species in such an immense universe is wonderful. Each enigma we solve takes us nearer to knowing how we came to be and where we are headed. Methuselah's weak light, traveling for almost 14 billion years, arrives at our telescopes as a faint call from the beginning of time. In it, we see not just the past of one star but maybe the past of everything. The coming decades hold even more surprises in store. James Webb will look deeper into the early universe. Gaia will update its chart of our galaxy. The Nancy Grace Roman Telescope, launching soon, will search the sky for dark energy signature. Each will probe our theories to their limits. Maybe they will verify the standard model. Maybe they will require us to extend it. Either way, the universe won't cease to astonish us. The Methuselah paradox is not just an interesting aside. It is a reminder that science is never done, never concluded. Every solution creates new questions. Every answer uncovers new mysteries. The universe owes us nothing in terms of simplicity. Rather, it asks us to enter the complexity, to challenge us to think larger, to live with uncertainty, and to continue to look up. Amidst all of this, Methuselah's light remains, old and steady, whispering over the void that the truths we are looking for are still waiting. With every observation, we inch ourselves closer, not only to realizing the age of the universe, but to learning our position in it. Until then, we remain seekers at the threshold of knowledge, chastened by the vastness of time, and in awe of the secrets yet to come.